This time, let's practice finding the antiderivative of several algebraic expressions. Let's call these algebraic integrals. Let's move on with the first example. So let's find the antiderivative of the binomial 3x plus 10 to the 4. Remember the power rule, which says that the integral of u to the n du is equal to u to the n plus 1 over n plus 1 plus c, where u can be any function of x. For example, in this case, u can be 3x plus 10. So if we take the derivative of u, we can see that it will be equal to 3. From this equation, we can solve for x. And the solution is dx is equal to du over 3. And using our definition of u and dx, we can rewrite the original equation as follows. We'll have the integral of u to the 4 dx over 3. So 1/3 is a constant factor, and we can take it out of the integral. And we will integrate now u to the 4, applying the power rule. So the solution is 1/3 times u to the 5 over 5 plus c, which is equal to u to the 5 over 15 plus c. Now let's find the antiderivative of this expression. In this case, we can have two approaches to find the antiderivative. In the first case, we can choose u to be equal to x squared minus 3. We can find the derivative of u with respect to x, which is equal to 2x, and from this equation we can solve for dx, which will be equal to du over 2x. With this, we can rewrite our original integral as follows. Instead of writing x squared minus 3, we will write simple u. Okay, instead of dx, we're going to write du over 2x. And x divided by x will be equal to 1, and these 2 can be taken out of the integral because it is a constant factor, and our integral will be 1/2 the integral of u squared du. So we can use the power rule to find the solution for this equation. And it will be u to the 3, and since u is equal to x squared minus 3, we can replace it, as you can see in the solution. Okay, for the second approach, we can develop the given binomial x squared minus 3 to the 2, which is equal to x squared minus 6x squared plus 9 times x. And we can develop this product, and we'll have x times x4 is equal to x to the 5, x times minus 6 x to the 2 will be minus 6x to the 3 plus 9x. We can separate these three terms in three integrals, and then we can finally apply the power rule to find the solution. As you can see here, this solution is different from this one. So it seems we have two solutions. How can we find which one is the good one? Well, remember that we're finding the antiderivative. So if we take the derivative of our solution, we should have the original integrand. So let's find the derivative of the first one. This is our solution, and the derivative of this solution will be equal to 3 divided by 6, x squared minus 3 to the 2 times 2x, which can be simplified as x times x squared minus 3 to the 2. So we can see that our solution is correct. Now let's work with the second one. We can take the derivative of the second one, and as you can see here, the solution will be x to the 5 minus 6 times x cubed plus 9x plus 0, which can be simplified as x times x to the 4 minus 6 times x squared plus 9, and can be rewritten as x times x squared minus 3 squared. So you can see that this is a solution too. Of course, both solutions are equivalent. Now let's talk about an exception to the power rule. You have already noticed that it is not possible to find the integral of 1 over x dx, which is the same as the integral of x to the negative 1 dx, using the power rule. But of course there is a solution for this integral. You already know that the derivative of the logarithm of x is equal to 1 over x. So it's easily find that the integral of 1 over x will be equal to the logarithm of x. In general, the integral of 1 over u du will be equal to the logarithm of u plus c. Now, with this exception to the power rule, we can find the solution to integrals like this one. In this case, let's choose u equal to 13x minus 7. If we take the derivative of u, we will see that it is equal to 13. And solving for dx, we will have dx equal to du over 13. Using this result to rewrite our original integral, using u equal to 13 minus 7 and replacing dx with du over 13, we will have this expression 1 over 13, the integral of 1 over u du. In this case, it will be 113 times log of u plus c. Let's apply the same technique to find the solution of the integral of the cubic binomial of 4 root of x minus 1. So let's define u as the binomial 4 root of x minus 1. We need to find the derivative of u in order to define dx. The derivative of not the square, 4 root of x is equal to 1/4 x to the 1/4 minus 1, where 1 can be written as 4 over 4. So the derivative will be equal to 1/4 x to the negative 3/4. From this equation we can solve for dx, and dx will be 4 times x to the 3/4 du. Using this expression for dx, we can replace it in our original integrand, and we can use u instead of the binomial. So our integral can be rewritten as the integral of u to the 3 times 4 times x to the 3/4 du. And as you can see, we don't have an integral of the following form, and this is what we are looking for in order to apply the power rule. But we have here a term that it is not possible to use it to apply the power rule. So in cases like this one, we can use this approach. Then, how do you find the solution for this integral? Well, instead of trying to define a function u of x, we simply do the math. In this case, we develop the cube binomial. And remember that the cube binomial is equal to the cube of the first minus 3 times the square of the first by the second plus 3 times the first by the square of the second minus the second to the 3. Having this, we can separate our integral in 4 terms, and then we simply apply the power rule to find the solution, and we simplify our solution, and that's it. Whenever you are trying to find the antiderivative of algebraic expression, you can have these points in mind. First, you have to rewrite the integrand as a sum of terms. You can do this using the power of algebra, like factoring, developing a binomial, applying exponent rules, dividing polynomials, etc. And then you can use the indefinite integral properties that we have listed in class. And finally, you apply the so-called power rule to get your solution. That's all for now. You have homework to do, and it's already in Blackboard.